Hello, this is Mr. Wynn, and today's video will be about the remainder and factor theorems. So, synthetic division can be used to find the value of a function. So we call synthetic substitution, but first, I'm not going to do that yet. I'm going to do it the old way. So if I give you a function of f of x equals 3x to the fourth minus 2x cubed plus 5x plus 2, find f of 4. Remember, this is where x goes. This just means plug in x is 4. So f of 4 means 3 times 4 to the fourth power minus 2 times 4 cubed plus 5 times 4 plus 2. You could put that in your calculator, or I'll go one step at a time. So this is really 768 minus 128 plus 20 plus 2. So that in the end turns into 662. Right, so we can plug in 4 for x and get that answer. Now let me show you synthetic substitution. It's just like synthetic division, just has a different name. So let's put that away. So remember, in the box is the root, or x. So I'll put 4 in here. Alright, next is coefficients. The degree is 4. There should be 5 things. I see it's missing a squared term. So it's 3, negative 2. It's missing that, so 0, 5, 2. Bring down the first number, multiply the number in the box, get 12. Add like normal is 10. Multiply the number in the box, get 40. Add like normal is 40. Multiply, get 160. Add like normal is 165. Multiply, that is 660. Add like normal is 662. Same answer as before. Right, so instead of just plugging x, you could do synthetic substitution or synthetic division with the number. That remainder is what the answer is. So, the synthetic division below showed that the quotient of that 2x cubed thing and x plus 3 is that other number. So y'all are used to saying that this would be what left over, so that would be what? 2x squared minus 9x plus 10. So this times what our original factor was, x plus 3, would give us back the original. So when we have an original function and we divide it by something linear to the first power, we get something that's 1 degree less, 1 degree lower. That is what we call a depressed polynomial. It says 1 degree less than the original polynomial. And let's see, notice the remainder is 0. If the remainder is 0, that means it divided evenly. You could do long division or synthetic, so that means it's a factor. So that's a special case of the remainder theorem. So the factor theorem can be used to determine whether a binomial is a factor of a polynomial or not. And it can help us find all the factors of the polynomial if you combine that with synthetic division. So determine whether this is a factor of that. Then find the remaining factors. Well, to see if it's a factor, I need to make sure it divides or goes in evenly. So I'll try it. Make sure you change the sign, so it's positive 5. The polynomial has a degree of 3. There should be 4 terms, what there are. It's 1, negative 7, 7, 15. Alright, so synthetic division. Remember, bring down the first thing. Multiply it. 1 times 5 is 5. Add like normal gives me negative 2. Multiply gives me negative 10. Adds it gives me negative 3. Multiply gives me negative 15. That gives us 0. So that is really 1x squared minus 2x minus 3. So it is a factor. Now to find the rest of these, I'm going to keep doing synthetic division. So let's try this. You could do the x method, but I'm just going to guess. Let's see. I'm going to try. Let's try negative 3. Alright. Well, degree is 2. There should be 3 things. Those are, it's 1, negative 2, negative 3. I'll try synthetic again. Bring this down. Let's use green. Multiply is negative 3. Gives me negative 5. Gives me positive 15. Gives me 12. That is not 0, so that failed. Alright, let's try something else. Maybe positive 3. Alright, we do not have to repeat the 5 again because that's already a root. So 1, -2, -3. Let's give it a shot now. Bring this down, gives me 1, multiply, gives me 3. Bring it down, gives me 1, multiply, gives me 3, gives me 0. So I know this is really x plus 1. Well, my last root's -1. Right? So turn these on to factors. So I know the roots are 5, 3, and -1. So remember, turn factors, you just change the sign, put next to x, so it's really x plus, oops, not that, x minus 5 is a factor, x minus 3 is a factor, and x plus 1. That's our equation. Right? If you FOIL that 2 at a time, then distributed, you would get the original problem back. So there are 3 factors, there are 3 roots here. If I graph that, you'll see x-intercept at 5, 3, and -1. So here's your practice problem. Find what f of 3 is. You could plug in 3 for x, but try using synthetic substitution or synthetic division. You should get 100. Again, this is Mr. Nguyen. Thanks for watching. See you in class.